We're going to do another kinetic energy problem. So this is going to be a kinetic energy problem. Uh, Kinetic energy is equal to 1/2 of the mass velocity to the square. And we said in the other video that the kinetic energy is the energy that shows up whenever a particle that has mass is moving with certain velocity. So just because the particle with mass is moving, it generates kinetic energy because of the motion. And it shows up because of that. So here is the problem. And this problem is so we can practice how to use a scientific notation. It helps. So we have a particle that is moving. So a particle is moving. And it's going to be this particle right here. Let's say it's this particle, and it has a mass. It has a mass of, it has a mass of 9.1 times 10 to the minus 31 kilograms. So that's the mass of the electron. So that's the mass of this little particle. And because it moves, it generates a kinetic energy of 4.5 electron volts. Just because it's moving, it generates that kinetic energy. And we want to find the velocity at which this particle is moving, the velocity at which it's moving. So it's going to be 4.5 electron volts. It's going to be equal to 1/2 of the mass, but we know the mass is going to be 9.1 times 10 to the minus 31 kilograms. And we're looking for the velocity, but this is velocity to the square. So we know that 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So that's what 1 electron volt is. And let's plug it over here. So this is going to be 4.5. And we're going to have here the electron volt is this one over here, this one right here. And it's going to be 1.6 times 10 to the minus 19 joules. This is J for joules. And that's equal to what? That's equal to 1/2 of the mass, which is 9.1 times 10 to the minus 31 kilograms times the velocity to the square. Now, why did we change this to joules, the electron volts? Electron volts, we went to units of joules. The reason we did that is because we have kilograms over here. We have kilograms, and the kilograms go well with joules. Kilograms do not go well with electron volts. We'll see in a minute. So let's do this multiplication here. So what we have here is if we multiply these two guys, it's going to be 7.2 times 10 to the minus 19 joules. And that's equal to 9.1 divided by half. So it's going to be 4.55. It's going to be 4.55 times 10 to the minus 31 kilograms times velocity to the square. So that's what we have right here. Let's divide this. Let's divide by 4.55 times 10 to the minus 31 and divide this one by the same thing, 4.55 times 10 to the minus 31, okay, kilograms. And kilograms over here. So this cancels with this and this cancels with this. So we'll continue over here. So we have that 7.2 divided by that is going to give you 7.2 divided by 4.55 is going to throw you 1.58 times 10 to the minus 19 times 10 to the 31 positive. Because this one here, the 10 to the minus 31 goes upstairs from the denominator to the numerator, and it changes the sign. And we still have joules over kilogram, and that's equal to the velocity to the square. Okay. So this is 1.58 times 10 to the minus 19 plus 31 is going to throw you a positive 12 up here. And you got joules over kilogram, which is equal to velocity to the square. And then you got to get rid of the square. So you get the square root of this one, the square root of this one, the square root cancels with the square. And you got the square root of 1.58 times the square. I'm going to write it like this. It's the square root of 10 to the 12. And you still have to get the square root of joule over kilogram, 1/2, and that's equal to the velocity. We need to remember that the square root is the same thing as elevating to the 1/2. It's the same thing. So there we go. And we are breaking this in factors. So 158, if you get the square root of that, is going to give you 1.26. 1.26 times 10 to the 12 divided by 2 is going to be 6. And you still have to worry about this joule, but joule is Newton times meter. And that is divided by kilogram, and you still have to get the square root of these guys, and that's equal to the velocity. So you got 1.26 times 10 to the 6. Newton is defined as kilogram meter over second to the square, and that's times the meter, and that's divided by kilogram, and all that is elevated to the 1/2, and that's going to throw you your velocity. So you got that your kilogram is going to cancel with the kilogram. Meter times meter is going to give you meter to the square. So I'll do it over here. So this is going to be equal to 1.26 times 10 to the 6. And then you got meters to the square over seconds to the square, but you still have to get the square root of this. And this is going to throw you 1.26 times 10 to the 6. So this is going to be 2 divided by 2. And in the that's in the numerator, these guys over here. And the denominator is the same thing. So it's going to be 2 divided by 2. So it's going to be meters over second. And there you go. That would be your answer. This is your velocity. It's a very slow moving electron. But a velocity of 1.26 times 10 to the 6 meters per second for an electron is going to throw you a kinetic energy of 4.5 electron volts. And there you go. You have a problem of kinetic energy. And we'll do more where we're going to use kinetic energy and potential energy. Thank you. I'll see you in the next one.